Hi everyone. We are going to start today with your 3.3 notes. And this section covers slope. So we're going to start with our explore activity, which says the graph shows the distance a car travels as a function of the time it travels. So we're going to first look at using the first 2 points shown on the graph to find this ratio, the increase in distance over the increase in time. So when we look at our graph, along the horizontal axis, we have time in hours, and along the vertical axis, we have distance in miles. So it's asking us to use those first 2 points to find the increase in distance. And if we look at the distance, it is 60 miles. And the increase in time, which was 1 hour. The next thing that it asks us to do is to repeat it for steps for points, the second point and the fourth point. So I'm going to go ahead and do that for the second point and the fourth point. And if you look, they have it labeled for us as well. So the increase in distance is 120 miles. And the increase in time is 2 hours. And we're going to go ahead and simplify those fractions. So this one is the same as 60 over 1, or 60 miles per hour. When we look at this one, 120 over 2 is the same as 60 over 1, or 60 miles per hour. So we can see that both of the ratios are equal when they are simplified. So part B then says, because there is a constant rate of change of distance to time, the points fall in a line. For the car, what does this rate of change represent? And it represents our speed. All right, so, and we're going to skip C. The rate of change in the distance and time data in the explore problem is known as the slope of a line through points. The slope measures the steepness of the line, but also gives the speed for the car in context. So in this section, we're going to explore several different contexts and many different perspectives. It might be numerical, it might be physical, or graphical. And you're going to learn how to calculate the slope in those different contexts. So slope is a numeric value of the steepness of a line. It can be found by computing the rise of the line to its run, and the slope is usually used with the symbol m. Slope may be given as a fraction, decimal, or percent. So an example of slope is to say when we use percent, we can say a road has a 5% grade, means that there are 5 units of vertical change for every 100 units of horizontal change. So you would see 5 for every 100. That would mean a 5% grade. This can also be simplified to 1 over 20 because 5 over 100 is the same as 1 over 20. It can be in terms of miles or meters, so the length could be based on both of those. But the rise can be up or down depending on whether the road is ascending or descending. As a fraction for slope, you may see that they give you a model that would be a ratio like we worked on in section 14. It might be 2 clients per month, which would look like 2 clients for every 1 month. Okay, so example 1 says plot the points A, B, and C and find the slope that passes through the points. So I'm first going to plot the point A at -1, -1. So that is A. B is at 0, 1. And C is at 1, 3. And it says to find the slope of the line that passes through the point. So let's go ahead and test it first from A, oh, and this one is C, let me label that, A to B. So when we look at A to B, we're first going to find the rise. So the rise is 2, the run is 1. Because you're going to think of the vertical change over the horizontal change. So we end up with 2 over 1, or 2. Let's next look at B to C. To go from B to C, we would have a rise of 2 and a run of 1. So we would also have 2 for that slope. And then let's go all the way from A to C. We went from A to C, we would have a rise of 4 and a run of 2. And 4 over 2 is the same as 2 over 1, or just 2. So all of these, going from one to the next, have the same slope. For example 2, it says to use the graph to find the slope of the point that passes through, or the slope of the line, it should say, the slope of the line that passes through the points -3, -2, and 1, -5. The first thing that we're going to do is plot those 2 points. So we have -3, -2, and the other point is 1, -5. Okay, so our line is right there. We can see that the rise, or the vertical change, it goes down 3, and our horizontal change is that it goes to the right 4. So our slope, which is represented by M, is -3 over 4. So we have been told that the idea for slope is that we have rise over run. We also know that M is the same as slope. I do not want to write that L. There we go. And one other piece of information that you can think of this is it is the horizontal over the vertical. Sometimes you might also see this written as the change in y over the change in x. So the triangle just means change. So this is a formula that you can use based on what we know about our points here. If our first point is x1, y1, and the second point is x2, y2, you can use this formula right here to find your slope. And that's what we're really going to be doing for a lot of the problems coming up. So this is an important formula. One other thing that I want to mention is if you have a vertical line like this, your slope is undefined. And all of your x values are the same. So when you have a vertical line like that, it is the same x values. If you have a horizontal line like this, your slope is equal to 0, and this has the same y values. Okay. So this blue box right here goes through how to use your formula for slope to find the slope between 2 points, we're just going to go straight into an example. Also, types of slope. This is something that I did briefly mention at the top of this page. Lines that are increasing from left to right have positive slopes. So all of these over here are positive. So anywhere between here and here are positive slopes. Any of the lines that are decreasing are negative slopes. So all of these on this side over here, because you can see that they're decreasing from left to right, all of those would be negative. Now we also have a slope that's undefined. A slope that is a vertical line is going to be undefined. And a line that is horizontal, like this one, is going to have a slope of 0. Okay. And you can see that this is also a way to explain it as well. So example 3 says, for each pair of points, find the slope of the line that passes through them by using the slope formula. Draw a sketch of the points and the line connecting them to help you make sense of the slope. Okay, so the first point that we have in this one is 1, 1. And the second point is 6, 4. So it's a little bit off of our graph. Okay. So my slope formula is m equals y2 minus y1 over x2 minus x1. So my first point has my first x and my first y. My second point has my second x and my second y. So I'm going to use this one minus this one, so 4 minus 1 over 6 minus 1. So I get 3 over 5, and that would be m. And if you look visually, you can see that we went up 3 over 5. For b, we're going to use that same formula. For this one, first point is at negative 3, 5. And my second point is at 3, negative 5. So I should see a negative slope because I can see that I'm going left to right, I am going down, I am decreasing. So I'm going to take my second y minus my first y. Then I'm going to take my second x minus my first x. So I would have negative 10 over, and this would become 3 plus 3, so 6. So I would have negative 5 over 3. And I can see that I would be going down 10 over 6, so it makes sense. So my slope is negative 5 over 3. The next one that we have is at 2, 3 and at 5, 3. So my line here is a horizontal line. So it's horizontal, and I can see that I have the same y values. So if I have the same y values and it's a horizontal line, my slope is going to be equal to 0. And I can even show you guys this using the formula. Let's say that we take our second y minus our first y over 5 minus 2. So I would have 0 divided by 3, which is 0. So any way that I look at it, I can see that my slope is 0. Okay, last one like this. We have the points 2, 3, and 2, 5. All right, now this one is a vertical line, and I can see that I have the same x values. So with ones like that, when you have a vertical line, your slope is undefined. And I'll show you how we can even get that with the formula. So if we use our formula, take your second y minus your first y over your second x minus your first x. So we get 2 over 0. And if you try dividing in your calculator, it'll tell you math error. And that's because you can't divide by 0. So that's why it is undefined. Okay. Example 4 says, for this one, we're going to skip that one because it uses both feet and inches, so I'm not too concerned about that one. And same with 5. But we're going to go ahead and look at using our table to find the slope. So in chapter 1, you learned how to look at the change in the y values of a set of points and determine if the points show a relationship that's linear, exponential, or neither. In each set of points, the x values were consecutive integers, meaning they were going up by 1. And this table shows that same kind of thing. To check for linearity, we looked for a constant amount added or subtracted for the y values. In the table below, the y values increase by 11 each, and they do that as all of the x values increase by 1. This indicates a linear relationship. So now with that understanding of slope, you're going to be able to assess linearity even if the points do not have consecutive x integers. Since lines have a constant rate of change between points on them, a constant slope is enough to determine if the points fall in a line. So for each set of points on the next page, you're going to determine if the data is linear without drawing a graph. If the data is linear, you're going to give the rate of change, which is just your slope, or m. So let's go ahead and start with A. What we want to do here is we want to find, and actually I'm going to have us first start with B and not worry about A just because of the decimals. So looking at this one, we're going to find what the change is from one y value to the next. So from 0 to 5, that's an increase of 5. 5 to 10, increase of 5. 10 to 15, that's an increase of 5. All right, so we can see that all of them on the right side for the y values keep increasing by the same values. Let's see if the same is true for the x's. All right, to go from negative 140 to negative 123, I would have added 17. Let's see if that works for the next. Yes. Negative 123 plus 17 is negative 106. And again, if I add 17 again, I would get negative 89. So remember that your slope is the change in your y values over the change in your x values. So we would have 5 over 17. Okay, I'm going to have us look at a few problems on the next page. For this page, you are going to use your slope formula for most of it. For number 1, it says, find the slope of the line that passes through those points. So you're going to use your formula for slope. So we have this as our first x and first y, second x, second y. So I'm going to have negative 3 minus 11 over 2 minus negative 8. So this would be negative 14 over 10, and that can simplify to negative 7 over 5. Let's go ahead and jump to number 3. If we look at number 3, we can see that the x values are the same. That would mean that if we have the same x values, it's undefined, and I can even have us do the math to support that. So take your second y minus your first y and put that over the second x minus the first x. So for the bottom, we get 0. And we can't divide by 0, can't do it, so we get undefined. And let's also look at number 5. Find the slope of the line that passes through these points. And if you look at your points, you can see that they have the same y values. If they have the same y values, your slope is 0. And we can show that by having 6 minus 6 for the top. For the bottom, it would be 1 minus negative 4. So we would have 0 divided by 5, which is just 0. All right, for this one, we're going to find the slope of the line. I can either use the graph or use the points. When I look at, my graph here, I've got the first point is at a height of 1, and then it goes all the way up to here, which is at a height of 8. So it went from 1 to 8, so it went up 7. And then let's look at the horizontal change. It started at 6, and then it went to 7, 8, 9. So from 6 to 9, we have a change of 3. So our slope is the change in y over the change in x, or the vertical over the horizontal. So we would have 7 over 3. This one, it only goes up 1, but it goes over 3. So our slope would be 1 over 3. If it asked you to draw a positive slope, you would want anything that increases from the left to the right. So that would work. A really steep line could work. An almost steep line, like that, it's only a little bit steep. Any of these would work. Okay, a 0, a line with a slope of 0, is going to be horizontal. So anything like this would work. Any of these would be fine. For a negative line, anything that is decreasing from the left to the right. It can be really steep, or it doesn't have to be too steep at all. So any of these would work. Okay. And for D, undefined, an undefined line will be completely vertical. So any vertical line would work. Okay. Number 9 says, find the rate of change in the following table. So we want to find the change in y over the change in x. So I'm going to see what these change by in the y's. We can see that it's changing by going down 5. It's decreasing by 5. The change in the x values is that it's increasing by 1. So I can write this as -5/1 or -5. Same thing for this one. If we look at the pattern here, we can see that these are increasing by 2. So the change in y is a +2, and the x values are a +1. So it would be 2/1 or 2. Number 11 says, ramp A climbs steadily for 28 yards over a horizontal distance of 310 yards. So let's go ahead and draw what that would look like. So it is vertical change of 28 and a horizontal change of 310. For ramp B, it says it climbs 15 yards over a distance that's horizontal of 190. So what we can do to figure out which is steeper is we can write these as decimals. So I'm going to take 28 divided by 310, and in my calculator I get 0.090. For B, I'm going to take 15 divided by 190, and I get 0.078. So because ramp A has a higher value for the slope, we can say that ramp A is steeper. For number 12, the pitch of a roof is its slope. Find the pitch of the roof. So we want to find the slope of the roof. So we want to find the change in y over the change in x. And you can think of that as vertical and horizontal. So the vertical change is 6. The horizontal change is 13. For number 13, it says a section of roller coaster track has the dimensions shown in the diagram. Find the grade of the track, which is written with the slope as a %. So let's have our vertical over our horizontal. So the vertical change is 9.18 and the horizontal is 27. So we're going to change it from a fraction to a % by first making it a decimal. So if we change it to a decimal and we divide, we get 0.34. And that is the same as 34%. Okay, that wraps up everything that you need to know for your section 3.3 notes. If you guys have any questions, just let me know.